Hi, everyone. I'm excited to have you here with me for episode 809 of People Behind the Science. I'm your host, Dr. Marie McNeely, and today we are revisiting our interview with our guest, Dr. Kevin France. Listeners, Kevin is working to better understand planetary systems outside of our own solar system. His research helps determine how the Earth was formed, how it came to look the way it does, and how it fits into the broader perspective of planetary systems throughout the galaxy. He also does laboratory and space mission work to develop the technology that will allow his group to answer some of these questions. And during our conversation, Kevin gave us a glimpse into his fascinating research, as well as his interests in life outside the lab. So listeners, I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Listeners, today I am excited to introduce you all to Dr. Kevin France. So, Kevin, welcome to our show today. How are you?
I'm doing great. Thanks for inviting me.
Absolutely. We are excited to learn more about you and your work. But before we jump into all the details, I do want to tell our listeners a little bit about you first. So listeners, Kevin is an assistant professor in the Department for Astrophysical and Planetary Sciences, as well as an investigator within the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder. He received his bachelor's degree in Physics and Astronomy from Boston University, and Kevin was awarded his Ph.D. in Astrophysics from Johns Hopkins University. Afterwards, he conducted research as a postdoctoral fellow at the University of Toronto, and Kevin next worked as a research associate and fellow at the Center for Astrophysics and Space Astronomy at the University of Colorado Boulder. And during this time, he was awarded the NASA Nancy Grace Roman Technology Fellowship. And listeners, Kevin has joined us today to chat about his work as well as his life outside the lab. So today, Kevin, we want to get to know you both as a scientist, but also just as a person. So can you start by telling us what you like to do when you're not doing science?
Right. All 2 hours of the day of that. So I moved to Colorado about 10 and a half years ago, primarily for work. But I found that sort of the outdoor lifestyle, living in the mountains here, suits me. So I'm a pretty keen hiker and skier. I like to bike and trail run. Those are things that used to be a little bit easier to do, but as work gets busier and I'm really fortunate to have a 9-month-old baby at home, it's been a little bit harder to find time to do those things. But those are kind of the outside of science activities I like to do when I can.
Fantastic. You got to wait maybe a couple of years, then you can take the kid out on the slopes, right?
Exactly. I know some people who do a hike that's 1 mile for every year that the kid is.
Aww.
Which seemed like a great idea when the kid was 4, 5, 6. But apparently by the time they're in their late teen years, this becomes a bit of a challenge.
Right. You're getting older. They're getting older. Yeah.
Yeah.
Understandable. Well, cool to get a window into your life outside of science. But Kevin, I do want to chat about your work next. So how do you describe your work to someone who's not at all familiar with your field?
I jokingly say that we're out to discover the mysteries of the universe. And that resonates with some people, actually. But really what I'm primarily interested in is how can we understand planetary systems that are beyond our solar system? What are the outstanding questions in terms of how did the Earth get formed? How did it come to look the way it is? And where does it fit in the broader perspective of planetary systems throughout the galaxy? And ultimately, of course, this sort of all leads to this "are we alone?" question. The existence and detection of life outside the solar system. I think those are sort of the big picture science questions that I work on, but I also do a lot of laboratory and small space mission work, which tries to develop some of the technology that's going to allow us to answer those questions.
Very cool. And I know there are quite a few mysteries of the universe left unexplored. And I always wonder, in a field like this, how do you choose the questions you're going to tackle?
In my case, I had to work with people that were older and smarter than I was, who told me what to start working on until I got deep enough into it to understand for myself what the next questions were supposed to be. And this is one of the things that I always find when I work with my graduate students that they feel kind of overwhelmed about is like, how do I decide what an important thing to work on is? And what I try to tell them is that if you stick around, it happens organically. you get involved, and then eventually you begin to develop your own intuition for what are the important questions that you want to work on.
Absolutely. And I love gleaning wisdom and motivation from those who are older and smarter, as you mentioned. So, Kevin, do you have a favorite quote or a saying or something that really keeps you going and motivated?
The one that sticks in my head, which is a little embarrassing, but if you remember in the George W. Bush administration, there was a call for a while to get rid of Donald Rumsfeld. And there was this great quote that you can find on YouTube if you search for it, where George Bush says that I'm the decider and I decide what I decide. And he goes on to talk about that kind of stuff. When I was beginning to move from having to ask other people what I should be working on to deciding what I work on, eventually I found myself running this rocket program here at CU. And it was a real change of mindset to go from asking what other people thought and using that to decide what we do to being the person in charge. And somebody told me that I was now the decider, and they found this George Bush quote for me. So ever since, I've kind of stuck with that, where remembering that I need to be actively engaged in everything I do. And I'm not the decider with everything, of course, but it comes back to the maturation of my science career anyways, to know that I actually am capable of being somebody who can decide what I should be working on when I get up in the morning, because I certainly didn't think that I could do that when I was, say, a grad student and an early postdoc.
Absolutely. And I think that's one of the challenging parts about this transition from being a graduate student or postdoc to being an independent investigator is now suddenly having all these decisions to make. So what really helped you in that process?
I think I felt like I was tossed into the deep end and then still had to seek out people who had done certain parts of this before. And also getting a lot of help from having great students. And I do a lot of technology work, so I had a really great engineering team, and building a good team that you could rely on. In a lot of ways, we learned how to do some of this stuff as a team, which certainly made it easier.
Absolutely. And I think at maybe these different key stages in your career, it's really helpful to have role models or other people that you can look up to. So when you think back on your own career, Kevin, are there certain people that really stick out in your mind as people who had a big impact on you or maybe inspired you at first to pursue science?
Absolutely. So I didn't really start pursuing science until I was in college. So not really from an early age, but I got involved in a research project when I was an undergraduate, and it gave me the opportunity to go to White Sands Missile Range to work on a sounding rocket launch. I guess it was over my 21st birthday. And it was the most amazing experience. And it sort of clicked for me at that point that sticking with astronomy was something that I could actually see myself doing and would think was cool day in and day out as a career. So those were the people who gave me my first job, even though I didn't really have any particular qualifications for it when I was in college. But then throughout the course of my career, I've been incredibly fortunate to work with my Ph.D. advisor, and particularly when I moved to Colorado to join the Cosmic Origin Spectrograph team. This is an instrument that we built here at CU for the Hubble Space Telescope. I got a chance to work with this team of people who were kind of doing the things that I was already interested in doing it, but really taking it to the next level. And I feel just very fortunate for the opportunities that I got doing that.
Absolutely. So can you tell us what officially turned your eye towards astronomy in the beginning in college? Was it an introductory course that you just happened to take, or was it a professor you happened to meet?
Well, when I went to college, I wasn't sure what I wanted to study. So I took all the classes that were required for a physics major and a French major, thinking that...
Very different, but yeah.
Yes, split the difference somewhere. And I'd never taken any astronomy classes, but I did take an intro astronomy class. And there was a lab my freshman year where we looked through relatively small, I think 8-inch telescopes that were on the roof of our astronomy department in Boston, where the looking at the sky is terrible from downtown Boston. Mm-hmm. But the image of Saturn with the rings and stuff was really spectacular. And I guess I'd gotten through 18 years with never having looked through a small telescope at Saturn before. But I think it was the first thing that made me decide that maybe science was the right choice. So it helped inform the classes that I took, and at least left that door open until I was really sure, basically after I had a research job and found that I really liked doing this.
Very cool. So what was the attraction to French, if I may ask? Aside from your last name, of course. Right.
Yeah. Well, the French thing actually came about. So I took it in high school, and I had the love of my life in high school, who is now my wife, and I were both taking French, but her mom was a Spanish teacher. And so when we were deciding what language to take, we had to take a language so we could communicate without our parents knowing. But it had to be a language that her mom did not also speak. Mm-hmm. So French was the answer, and we had a great French teacher, and sort of the rest was history there.
That's awesome. And now you mentioned this really influential experience at the White Sands Missile Range. Can you tell us a little bit more about what it was like to go there and actually take part in some of the research?
I kind of couldn't believe that they were letting a 21-year-old out there to do this. So I still work at White Sands Missile Range, pretty much worked there the rest of my career, so almost 20 years now. And being out in the desert, it's vast and empty and rugged and beautiful, but you're out there to do something. Where we're building an instrument to launch into space to make these measurements that no one has ever made before. Something about the confluence of all those things just really stuck for me. And I still go out and I still get that sort of sense of awe the first couple of days when we're out working at White Sands again. So it's something that even after doing it for a long time now, I still look forward to doing it every time we get to go down there.
Well, I love to hear that. People who are enthusiastic and excited about the work that they're doing. So now you decided to go to graduate school, and I mentioned in our introduction you went to Johns Hopkins. Can you tell us a little bit about your experience there?
So because of my experience with the rocket group at Boston University, I knew the right people to talk to about graduate school. So I was able to get into Johns Hopkins, and they also have a sounding rocket group there that I had the good fortune to get involved with right away as soon as I started grad school. And graduate school was surprisingly different than college. I kind of expected it to be a more sciencey version of college, but it was not. The experience was really wonderful, particularly the amount of responsibility that I was given to work on some of these rocket projects. It's always a small team. And again, I guess I wasn't 21 anymore, but for a 24-year-old to be handed the keys to a $2 million project, it's
a little scary. Yeah.
A little scary. It was the first part of this being okay with being the decider, I guess.
Absolutely. So then you went on next to do a postdoctoral fellowship. Can you tell us a little bit about some of these postdoctoral experiences?
The postdoc situation was always a little weird because it's by definition kind of impermanent. So I felt a little bit maybe fish out of water because I knew that I was going to be leaving wherever I went in 3 years at the most. So when I was in Toronto, I won't go through the whole story, but the Hubble servicing mission, the last Hubble servicing mission, which had been canceled, was reinstated. So they were building up this team here at Colorado for this instrument that I mentioned earlier, the Cosmic Origin Spectrograph. And I had this opportunity to leave Toronto early. Toronto was a great city, but the thought of coming here to work on an instrument that was just sort of right up my alley based on what I had been doing in grad school and my science interests, it just seemed too much to pass up. And in hindsight, having stayed here for the last 10 years after that, it seems like it worked out.
Yeah, absolutely. So now you are there at the University of Colorado Boulder right now working on a lot of amazing different projects. So do you have a favorite one, Kevin, that you want to give us a little bit more detail about today?
My favorite project right now is one that I'm not being funded to work on, which you'll rarely hear me say. But there are 4 large mission concept studies that are going on right now that are being supported by NASA. And I'm working on one of them that's called LUVOIR, which sounds French, but it's not, although it was coined by a French person. It stands for the Large Ultraviolet Optical Infrared Survey Telescope. And this is sort of like a super Hubble Space Telescope that will also be able to detect the signs of life in the atmospheres of Earth-like planets around other stars. This is a mission where if we start building it in the 2020s, I think we'll be able to launch it by roughly the mid-2030s. The science portfolio that this LUVOIR mission is capable of is really just mind-blowing. I mean, imagine the Hubble Space Telescope. Imagine the world without the Hubble Space Telescope, without all of the pictures and all of the results that we know about the expanding universe and atmospheres of extrasolar planets and all this amazing stuff. Now, take Hubble, but imagine that it was 100 times more powerful and had all this instrumentation to detect the signs of life in exoplanetary atmospheres.
That's almost overwhelming. Yeah.
It's overwhelming. It's mind-boggling. I'm certainly biased, but speaking just as a member of the community and not as a member of the LUVOIR team, I think it's just by far the most interesting and ambitious thing that we could be doing. So I'm really excited about working on it now.
Now, you mentioned the sort of time span of this project, already looking out into the 2020s, 2030s. What's it like having to, I guess, be that patient for the research that you're doing?
Yeah, that was definitely a sea change to be able to think that things that were 15 years down the road were not that far. I think maybe that's just being older. I'm not sure if that's a career development. I think this comes back to what you were saying about having to enjoy the work, because the path to get there is going to be even longer than probably my ability to do science with this instrument, if should we be so lucky to build it and launch it. So you have to sort of enjoy every day, or maybe you don't have to enjoy every day, but averaged over a lot of days, you have to enjoy it every day.
Right. The mean enjoyment has to be high. Yep.
Exactly. So really look forward to being involved in the process of what it's going to take to actually build the instruments, to put everything together. And then ultimately, of course, being able to answer some of these questions. And are we alone? And is an Earth-like planet common outside of the solar system? These are things that would just be unbelievable to know the answer to in my lifetime.
Absolutely. So is there a particular measurement or something that you're really, really hoping to find with this?
My involvement is partially on the side of understanding the conditions for terrestrial planets, rocky planets to form. I'm also interested in the atmospheres of these planets. And I think that the big signature science case of the LUVOIR mission is really to be able to search for the signs of life on other planets. And this "are we alone" kind of big question is really the thing that ultimately is the one that would be the most amazing to answer.
I think you're not alone in thinking about that, though, too.
I'm glad to hear it.
We're all wondering ourselves.
Yeah.
Well, you've got a lot of cool projects going on, like I said, and it's been great to chat about them and some of the different steps along your career path, Kevin. But so far, we've talked about a lot of the great things in your career. And I know there are down days as a scientist as well. It's not all exciting discoveries and wonderful progress. So can you talk to us a little bit about some of the challenges that you've faced, or maybe some of the big failures that you've had, and how you've gotten through them to continue on to be a successful scientist?
Sure. Yeah. Because not every day is roses. I think there are two big challenges that I can think of career-wise in my life. There's the process of growing up in graduate school I found very challenging. Even though I did fine in college, I found grad school to be quite daunting, and I had a lot of concern that I would kind of never be able to really cut it. I guess eventually kind of fake it till you make it, I've heard people say, and things work out. So that's sort of in general, but I remember a very specific time about 4 years ago or so. I was looking for a permanent job because my job here in Colorado wasn't permanent until a few years ago. And I'd been offered this faculty position, and this was supposed to be the greatest thing since sliced bread. And this is what I had been indoctrinated with, that you were supposed to get this faculty job and then life was perfect. And I got this offer and it didn't feel perfect. So against a lot of people's advice, I turned it down. And I thought that I would probably be okay because I had enough grant support and everything was going to be fine for a couple of years, until about 6 months later, I found out that I didn't win this big grant that I was really, really counting on.
Oh, no.
And so all of a sudden, this decision to turn down a very stable, permanent position seemed like it might have been an absolutely horrible mistake. And my wife and I had just bought our first house, and there was all these reasons that stability would have been really nice. And I felt like things were falling apart, and I was afraid that basically I had made a career-killing decision. It turns out that everything worked out in the end, but There were some dark nights of the soul there while it took a few months to kind of work things through and make sure there was going to be a happy ending.
So how did you get through this situation? I mean, this sounds like everyone's worst nightmare, right? You get this perfect faculty offer, you turn it down, you think everything's going to be fine. And then, like you said, everything just starts falling apart. What steps did you take to solve this insolvable problem?
Well, the first thing that I did that I didn't tell my graduate students that I do was I was imagining how far I could stretch out my funding if I fired them all. But I didn't tell them that.
It's probably a good thing.
Well, actually, as it turned out, there was a completely unanticipated opportunity here at the University of Colorado for somebody who was working at the intersection of space science and space technology. And this position just happened to be created completely independent of anything that I had done about the same time that all of this terrible stuff was happening. It was sort of like the universe handed me this job to apply for, and it ended up being my route into my current faculty position. So it was just kind of stuck with it, and the answer presented itself.
I like it. It's a little bit of the right place at the right time, but also I'm sure a lot of hard work went behind that too.
I think there was a lot of luck. Yeah.
Well, very cool. Thanks so much, Kevin, for telling us about one of these challenging situations you found yourself in and how you worked through it. But we don't just want to talk about these dark nights of the soul of yours. Let's talk about success next. I think you've had a lot of exciting successes thus far in your career. Do you have a favorite one that you want to tell us about today?
The one that I'm pretty keen on right now is We're building a small satellite for NASA called CUTE, and that stands for the Colorado Ultraviolet Transit Experiment. And CUTE is only NASA's second astronomy CubeSat mission, and we were selected to build this earlier in 2017. And what CUTE does is CUTE goes out and observes hot Jupiter planets orbiting nearby stars. And by hot Jupiter, we mean gas giant planets that are orbiting really, really close to their parent star. So they're being really heavily irradiated because they're so close, so much so that actually their atmospheres expand and can escape from the planet. They actually may expand and escape so much that they form comet-like tails that get drug around behind the planet as the planet orbits the star. So what CUTE's designed to do, it's a small telescope and a small spectrograph, and it's designed to go out and observe these planets as they cross in front of their parent stars, so during their transit periods. And during those periods, it takes spectra of the transit events. And using that spectra, we're able to measure how fast that planet is losing its atmosphere, what that atmosphere is made of, a few other things. But I'm really keen on this right now because to me seems like a very fun next step from building rocket experiments to building something that is going to stay in space for a while. I'm pretty excited about that. And it's also really great because it has a ton of student involvement. We have a few graduate students that are going to be working on it, getting their PhDs through this. And we do the operations right here on CU campus when our operations center for these small satellites is run by undergraduates. And so this is a really great opportunity for me to do something that I'm extremely interested in from a science perspective, but also basically turn it into an educational project, both at the undergraduate and graduate level. So I'm super excited about CUTE right now.
Absolutely. Well, I love the name as well. It's cute.
Oh, thank you.
So now, you mentioned when you were first getting your hands dirty in research, it was a little bit scary to suddenly be able to make some of these decisions. Now, being on the other side as a mentor, is it scary for you to let go and let students make some of those decisions?
I'm better about this in some areas than others. My general philosophy with this is that I'm happy to let a student do anything that they ask to do. And I begin to trust them after we go through it once or twice together and everything works out. But I don't think I've ever said no to something that a student asks to be in charge of, because I'm always delighted when a student is interested enough to take the initiative to say, look, I know this is sort of a high risk, high reward thing, but let me do this. So I always say yes to that. But sometimes I say yes and then do the same thing myself to make sure we all get the same answer.
It's okay to be a helicopter sometimes. We hover a little.
Exactly.
Very cool. Well, this sounds like an amazing project. Kevin, thanks so much for telling us a little bit more about it. And we talked a little bit about life outside of science, and it sounds like things are a little bit crazy these days with you in terms of having a 9-month-old, trying to keep everything running in the lab as well as managing your home life. But I love getting book recommendations from everyone that we have on the program. So do you have a favorite book? It doesn't have to be a recent one that you'd like to recommend for us today.
I'll recommend a science book and a non-science book. My favorite science book, I think, is Richard Feynman's The Pleasure of Finding Things Out. It's a series of short stories or short anecdotal experiences from Feynman's various exploits. And they're both funny and informative. Probably my favorite science book. The best non-science book that I read recently was probably The Goldfinch by Donna Tartt. It was kind of a heavy book, but it really stuck with me for a few months after I was done reading it. So I'd say that's probably my recommendation.
Excellent. Well, listeners, I will add these 2 books to our reading list on our website if you're looking for your next great read. And Kevin, one of the things we haven't really had a chance to chat about yet are some of the opportunities that you've had to travel as a scientist. And I think this is maybe one of the more lesser known perks of the careers. So I love highlighting it on our program. So do you have a favorite place that your science has taken you?
When you asked at the beginning what I like to do outside of science, travel is something that I feel very fortunate to be able to do as a scientist. And you're right, it is a big part of the job. So I mentioned White Sands Missile Range, and basically we live in southern New Mexico for about a month and it's great. So that's been a fantastic opportunity. Outside of that, there are meetings in really obscure places that astronomers manage to find. So the 2 that have been my favorite is I was in a meeting that was about 4 hours south of Kolkata, India a few years ago, right on Ganges River. And I'd never had imagined that I would find myself to an off the beaten path part of India, but research took me there. And then a lot of meetings also have a conference dinner or something like that. And I think the coolest one of those that I ever went to is that there was a concert that was associated with one of a meeting that I went to in Venice a few years ago for the 20th anniversary of the Hubble Space Telescope. And it was an octet playing in a 16th century monk's art studio that they had converted into this space for this octet to play. And it was the most beautiful room that I have ever been in. And this flat and Venice. So I would say that India and Venice were some of my greatest hits.
Oh, wow. Well, these two are both on my list of places that I need to go. So tell us a little bit about Venice. What is one of the things that you really enjoyed outside of this octet performance?
It's a walking city, or a walking and boating city, I guess. It's very refreshing to wake up in the morning and know wherever you were going to go was going to be without any cars, and everything that you needed was basically within a 15-minute walk of the area. And then the architecture is just absolutely beautiful. So I was also recently engaged at that point. So it was an extremely romantic opportunity to bring my then fiance to Italy, and it made me look like a really great fiance at that point.
Right. Did you do the little gondola ride?
Yeah, that was the whole 9 yards. Yeah.
Of course. I love it. So now tell us a little bit about India. You said you were in a relatively remote part. What was the occasion?
There was an International Astronomical Union symposium on supernova remnants. So these are the explosions of massive stars. And it was sponsored in part by the Tata Institute for Fundamental Research. And so I guess they had a contract arrangement with this old historic fort that was between Kolkata and the Bay of Bengal. So we all flew in, and they put us on these buses that sort of worked and sort of didn't work. And we went down there, and because apparently this Tata Institute also does a lot of nuclear research, so we had guards at the conference because we were considered being related to a state nuclear secret.
Right. You're suspicious characters. Yeah.
So I think it was to keep other people out as opposed to keep us in. Mm-hmm. But it was also the first time when I've ever felt important enough that there were guards where I was.
Very cool. Did you get to do any observing out there? It sounds like you might have had better lighting conditions than in Boston.
Yeah, the night skies were beautiful, but no observing out there.
Gotcha. Well, wonderful to hear about some of these amazing travel experiences. And I think in addition to the travel, the people that you get to work with are another reason science is so wonderful to be in. So we love to talk about what scientists are like and to maybe dispel some of these stereotypes that are out there about who's actually doing science. So I love sharing maybe fun traditions or quirky memories and things that scientists do that really show this more human side of the endeavor. So Kevin, do you have a story of your own you can share with us today?
When I was in graduate school, I was part of an all-graduate student rock band. We were known as IGWAD, which stands for Indian Guy with American Dreams, because our lead singer was from Bombay, India, and the rest of us were dreamy Americans.
Of course.
So we played in bars in Baltimore, Maryland for about 3 or 4 years, and we would play probably once or twice a week for a couple of years and played all over the place. And we weren't very good, so we ended up playing in a lot of seedy places. Mm-hmm. But it was the best stress relief that I found in grad school and a whole lot of fun.
That is awesome. So what did you play?
I play the drums.
Gotcha. Do you still play drums?
I do play the drums. Now that I finally live in a house, I can actually have my drums in my house. Living in an apartment, drums are not very apartment compatible.
It's no way to make friends, right?
Absolutely not. Yeah.
Gotcha. So do you have dreams to form another band then?
I would love to form another band. That is one thing I think in general that scientists are extremely musically inclined. I haven't yet found a group of non-student scientists here at Colorado to start a band with, but I would love to do that.
Fantastic. Well, I can agree with the musically inclined. I'm a violinist myself on the side, so.
See, there you go.
Well, we've chatted about some of the great work that you're doing in your laboratory, some of the big questions that you're answering. And I love challenging scientists to think outside of the box because I think so often we're constrained by resources and technology and things like that. So, Kevin, if I took away all the restrictions here today and gave you everything you needed, funding, staff, technology, feasibility, people, whatever you need, what is the one question you would want to answer?
I've got to come back to this LUVOIR mission. I think that answering this fundamental question is, are we alone? Are there other inhabited worlds outside the solar system is the number one question for me. And I think that if we were to knock down the barriers of funding and technology and feasibility, that would be the first thing that I would do. But I have to say that even with the challenges of all these things, it's going to take 15 years, but I do think that we will be able to answer those questions, hopefully in my working lifetime.
Absolutely. And I think one of the challenges with this "are we alone" question is the universe is such a massive place. Where do you even start looking? So do you have a particular place in mind that you'd want to look first?
We know a lot of nearby stars that have planets are, and nearby is important because those are going to be the brightest and easiest to study. So pretty much any star that we know that has a planetary system inside of about 30 light years is probably a really good place to look. And it turns out that there are quite a number of those. So I don't think we're short on good candidates at this point.
Gotcha. Well, thanks so much for dreaming big with us today. And I think, like I said, your question is one that many of us are waiting for you to answer. So pressure's on.
Right.
So we've talked about some of the different stages of your career and some of the people who influenced you along the way or maybe mentored you. And I think these people can be instrumental to helping you get through your career. So is there one piece of advice that you got at some point, Kevin, that really sticks out in your mind, that really helped you, that you can pass on to our listeners today?
Probably to not undervalue the importance of hard work. I think this was when I mentioned earlier the sort of having the uncertainties about if I had what it takes to basically have a career in science when I was in grad school. Somebody said that if you continue to work hard, you can probably do anything that you don't think you can do as long as you're willing to just keep plugging at it. And there's a well-known scientist from the University of Washington who wrote this paper recently describing this, I think, as grit. So the grittiness is a popular way to quantify scientists these days. This was before the age of grittiness, but I think this is what they were telling me, is that you just have to stick it out. And you can do things that you probably didn't think you could have done. Just got to be gritty.
I like it. Listeners, be gritty. And Kevin, I think you're absolutely right here in that so many of the things that you do as a professional scientist in a permanent position, you don't necessarily get explicit training on as a graduate student. You don't necessarily feel like you have all the preparations when you're sort of dumped into that deep end of the position. So were there any particular training tools or any particular skills that you found that you really had to develop quickly?
Certainly understanding the process and reality of funding was a big thing that I had a vague notion of, but didn't really understand, particularly as I began to realize that this is how you have to do this to support your own students and to basically support yourself. I never really realized that. Learning the ins and outs of funding and proposal writing and stuff like this were things that I'd had experiences with in grad school, but I didn't really appreciate how important they were and really how to do them all that well, that I definitely felt like we're on the job learning.
Absolutely. So has it been a lot of trial and error, or have you found that there are resources there at the University of Colorado that have really helped you?
I found that there are people at the University of Colorado that have really been very helpful. Nothing that I do is unique or doing for the first time. So being willing to admit you don't know something and going and find the person who has done this before is, I think, pretty invaluable. So being able to find the right person to ask, like, well, you've been in this position having to deal with a grant, like, how does this work? And what's the proposal situation for this? Just having a bit of humility to admit that you don't know stuff, which is not always what you're encouraged to do, but typically I found to be the fastest way to actually getting your confidence that you can do something.
I think you have to embrace the awkwardness and just go for it sometimes, right?
Absolutely, yeah.
Well, Kevin, thanks so much for sharing this advice. Can you tell our listeners, if they want to learn more about you and more about your work, where should they go?
You can go to my website, which you can just Google Kevin France and it will come up, or you can send me an email. It's just kevin.france@colorado.edu, and I'd be happy to talk or email or anything you want.
Sounds great. Well, listeners, definitely check out Kevin's website. He's got lots more detail about the projects he's working on there, and also get in touch if you have any particular questions. And Kevin, thank you so much for joining us today and sharing a piece of your story.
Thanks again for the invitation. I appreciate it.
Well, it was delightful to chat with you, and listeners, wonderful to have you here as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.